at the circle, we're going to lay out some basic information that we understand about rotation and degrees around a circle. So how many degrees are in a circle? 360 degrees in a circle. But for us to all be on the same page, we kind of have to have this idea of a starting point and an ending point. Okay? So I'm really not good at like centering myself and stuff up here, but whatever. Okay. So your circle starts, this is what we refer to as the starting point, okay, or our 0 degree edge. And just like in geometry, how you drew angles with like 2 rays or 2 segments or something like that, that's how each angle will be drawn, but it'll always be drawn from this as kind of the starting side of the angle. Okay? They call that the initial side of the angle. But that means that once you go around, the 0 is really the same as also being 360 because you would go around and end up in the same spot. Right? Because you guys told me there's 360 degrees in a circle. Is that okay? So this is our initial spot all the time. Okay? Think about kind of like the positive side of the x-axis or something. You can move around in different increments. You can even move different directions to draw different angles. Okay? All right, so looking at your paper, there's a couple things we're going to do. We're going to skip the radians first. We want to get a general idea of where some certain degrees are. So there are some things that are going to be extremely helpful for you to know. If this is 0 degrees, what would it be if I traveled from 0 degrees and we travel counterclockwise? Okay? And let's say I ended up over here. Sorry, clearly not straight. So this is my initial side at 0. I go around, and then they call this the terminal side, the place where the angle is ending. On the other side, how many degrees would that represent? 180, okay, half of our circle. So some other key things to know to split the circle up well. We have our 0. All the way around is 360. Therefore, halfway around is 180. What is a quarter of the way around the circle then? 90. Okay. So 90, 180. This one is not one we use as often. Like, those aren't odd things to hear. This one's not as often, but think about it. It's 180 degrees and 90 more. So it's 180 degrees plus an excess of 90 degrees. 270. Yeah. So these are going to be important things to know because if you want to put other angles into this circle, it's nice to have some things that you have that you can reference. Okay? So let's say that we want to put in, I'm going to cheat and use your paper. Let's say we want to put in 50 degrees. Where would we draw a 50-degree angle? About. Upper right hand, somewhere over here. Okay. Now, if I cut the 0 and 90 exactly in half, so if I went exactly half the distance I went to 90, what would that be? 45. So 50 is like a little further than that. Maybe something like right there. So I'm just drawing on some different angles so we get an idea when we see this what we think in our head. So when someone says 50 degrees, I think the angle that has an initial side at 0, a terminal side at 50, and basically is referring to that much right there. Okay? Where would 210 be? Yeah, so past 80. How many degrees past 80? 30. Okay, and that's going to become really important to us later because later on, these kind of axes across here are going to serve as our reference points. And instead of me being like, oh, yeah, 210, what I really want to know about it is that it's 30 degrees below 180. Big hint, 30, 60, 90 triangle stuff, okay? So 210 is going to be something we're actually going to know a lot about, specifically because it's got like this 30-degree difference between it and that horizontal line at 180. But right now, we're kind of just working on placing and understanding where these things would be. Okay? Can I cheat and use your paper? All right, we already marked 360. What about negative 45 and negative 200? So what does it mean to put a negative in front of the degree measure? Because that's kind of weird, right? Any idea what that means in this context? Before, it would have meant nothing to us. If your geometry teacher said draw a negative 45-degree angle, you'd be like, okay, sure, right? Huh? Good. So instead of counterclockwise, we would go clockwise. So from your 0, you go that way to measure any angle that's written in a positive degree. but we go this way to measure any angle that's written in a negative degree. So when they say negative 45 degrees, I could mark this angle right here and call it negative 45 degrees. But it actually has many other names. It actually has infinitely many other names, okay? If you didn't want to call that angle negative 45 degrees, can anybody give me another example of a measurement you could give me that would end in the same spot as the negative 45 degree angle ends? So it has this initial side, and it has this terminal side. Okay, so Matt says 315 degrees. So do you guys agree that if I start at this initial side and I go 315 degrees, it would look the same as what you drew as negative 45 degrees, right? Are those the only two names for that angle? Let me ask you this. Where would a 990 degree angle be? 990 degrees. It would go around and around. So let's see how many times. So it goes around, right? It goes around. So if I was going 990 degrees, I'd go around. There's 360. I'd go around again. There's 720. And according to my little arithmetic over here, I have 270 degrees left to go. So guess what? I would end up right here, and this is actually the same thing as 990 degrees. How many names are there that I could give each angle in degree measurements? Infinitely many. I can name them negative over and over again, just adding 360 to it, right? I can name them positive over and over again, just adding 360 to it. Okay. So the point is we just kind of want to understand how the measurements work, so when someone says a number, we can place it properly on there. So do we have a good idea of how that kind of operates? Okay, positive goes one way, negative goes the other. Now the issue is that each of these angles has a degree measure, but they also have a radian measure, this other unit that I was telling you guys about. Okay? So the easiest way to understand the radian measure is to remember your circumference formula. Does anybody remember how you calculate circumference of a circle? 2 pi r. Good. Okay. Now let's say I dictated that the radius of the circle was going to be 1. Okay? If the radius of the circle is forced to be 1, what is the circumference of the circle going to be? Okay. 2 pi times 1, which is just 2 pi. What does circumference measure? Not diameter. Around the circle. Just like the length of this, right? To get around it. So that coincides with kind of our angle measure. That means when I say that this right here is 50 degrees, and that tells me to start here, end here, and go this far, somebody else could tell me to do that same thing by telling me, hey, go a certain amount of radians, right? All the way around the circle would be 2 pi radians. So in radians, this is 2 pi, okay? 0 and 2 pi. What do you think this halfway around the circle is? If it's all the way around the circle is 2 pi, what is it to just go halfway around the circle? Pi, okay, or 1 pi. What do you think it is then to go here? Good, pi over 2. It gets a little confusing because we want to look at it and say, like, well, it's a quarter of a circle, so a lot of people want to call it pi over 4. But from here to here is pi. So half of that from here to just here would be pi over 2. Okay. Any idea what 270 would be in radians? 3 pi over 2, because it's like that's 1 pi over 2. That's 2 pi over 2. We just don't write 2 over 2. Okay. And that would make this amount 3 pi over 2. Now, we're going to get more and more kind of used to this idea, but we're going to look at how you can straight up convert it until you get more used to where those things are on the circle. Okay? So, looking at a couple of examples. So here are some degree measurements that we want to convert to radians. So we just talked about unit conversion, right? What are we starting with in this problem? Degrees, and we want to end up with radians. So remember we talked about, I'm going to write this out like one time just to get kind of used to it. We're going to have some amount of degrees. We're allowed to times it by something that's equal to 1. And what do we want to happen with the units is we want the degrees to cancel out, and we want to be left with radians, so that our answer says a certain amount of radians. I didn't put any numbers in there yet, but is this okay with what we talked about before about the hours and minutes and just kind of getting to the unit that we want? Okay? So the key to be able to do this is to know some relationship where a certain amount of radians and a certain amount of degrees are the same. So they're really just equal to 1, like we did over here. 60 minutes and 1 hour are the same. So yes, I multiplied by something, but what I multiplied by was just worth 1, so it didn't change the problem. Okay? So looking back at what we just talked about, can you give me a certain amount of radians that are equal to a certain amount of degrees so we could use them as our kind of conversion factor? So look at the circle. We marked degrees and radians at different spots. Is there a place where you can say, well, this many degrees is the same as this many radians? Okay. So 360 degrees is the same as 2 pi radians. Absolutely. So that means anytime we want to use a fraction that has the same amount, is really worth 1, we can use 2 pi over 360. Or we can use 360 over 2 pi. Now, this is a good ratio. It's actually not the one that people use most of the time. Does anybody know why they don't choose to use this one? Because of the 2, right? There's actually a way that this simplifies. What does this reduce to? Pi over 180. So they tend to use that one because it's simple. So this means anytime I want to convert from degrees to radians, I can use either of these. They're worth 1, okay, depending on what I want to convert to. So looking back at this, we are starting with 45 degrees. We're going to put radians on top and degrees in the denominator of our fraction in order to cancel out the degree unit and end up with the radian unit. Okay? So we said we're using pi and 180 as equal amounts of degrees and radians that can make a fraction of 1. Pi is a radian measure. 180 is a degree measure. So I'm going to use pi over 180 instead of 180 over pi just because of the way I'm trying to convert right now. Okay. So notice the setup here. These will cancel, okay, leaving me with 45 pi over 180. But I'm pretty sure that that reduces. Okay. 45 goes into each of those, actually. 45 goes into 180. Thank you. 4 times. So I get pi over 4 radians. So 45 degrees is the same thing as saying pi over 4 radians. Is that okay? Yes. Yeah, just like this. Okay? Fraction, but just in its reduced form. Okay? All right, so let's try going the other way. Okay, let's say they give us radians and we want to know what it is in degrees. So let's say we start with the pi over 3 radians. Can I abbreviate degree and radians because I'm lazy? Okay, thank you. Okay, and we want to end up with degrees. Okay. Which means when I multiply here by 1, I want the units of radians to cancel out. And I want to end up with a unit of degrees. So this is going to allow the radians to cancel out. And I'm going to do multiplication and end up with degrees. We know that pi and 180, so this is something we have to learn and memorize, is the ratio where we have the same amount of radians with the same amount of degrees. So it's always pi and 180. It's just which one goes where. But remember that pi is radians and 180 is degrees. Okay? So then we can see our units cancel here like we wanted. Pi happens to be a common factor in the numerator and denominator, so that cancels. We end up with 180 over 3, which is really the same thing as 60 degrees. Okay. So I'm getting it back from what we figured out about the circle. So I'm going back here and saying, just like if we wanted to convert minutes to hours, we had to know in our mind a certain amount of minutes that were in a certain amount of hours so we could build an equal fraction. So from my circle, I use this because it's the most reduced version, that 1 pi is the same as 180 degrees, yeah. And so that's what I can use now every single time. I just have to put it in the right spot. Okay. All right. So then the only thing we're going to add to this is this word called coterminal angles. You guys already did this. You just didn't know you were doing it. Okay? So back over here. I'm going to keep flipping slides. Sorry. It's annoying. Remember how I drew this angle that terminated, or its terminal side was at negative 45 degrees? But then I asked you guys for another name for it, and you told me it's the same as having 315 degrees, and we decided there were actually infinitely names that you could give that angle as far as number of degrees. Negative 45 and 315 are coterminal angles, okay? Because they share that terminal side. Okay? So coterminal is the vocabulary word for what you guys already did. So it really means give me another name for the angle that ends in the same place. Is that all right? So like you already did it, so the directions now just look a little more official. So they say, give me a coterminal angle. Okay? So an angle that's coterminal with 135. So if you have to, you can draw yourself a little picture. Okay? I don't know. I know that this is 0 and this is 180. This is 90. So somewhere right over here is 135. So what's another way I can name an angle that ends at that same spot as 135? So it's just kind of some arithmetic you have to play with 360, right? It tells us to give one positive and one negative. So what's a negative angle that ends in the same spot as this 135 right here? So negative 225. So Skylar's getting that by going the negative 180 and then 45 more. So negative 225 is an angle that would end in the same spot as 135. What's another quick arithmetic way you could have gotten that answer? You guys could have done 360 minus 135, and you would have come up with 225 as the extra portion, and just say negative in front of it. How can I end up with another positive angle that ends in the same spot? Go all the way around and then back, which means how many degrees am I adding to this? 360. Okay, so 360 plus 135. Yeah, so 495. Okay, so that's one positive and one negative. Now, for the radians, okay, there's a couple ways you guys can do this. Okay. Essentially here, to get these two numbers, what did we do without the picture? So to get 495 from 135 with the arithmetic, what did you do to 135 to end up at 495? Add 360. How did we get negative 225 from 135 if we just used arithmetic? Subtract 360. Okay? So if you want to make it a little easier on yourself, you can always add 360s or subtract 360s from your number. Okay? But that means when you get into radian world, okay, are you going to add 360 to that? Those are like two different units, okay, radians and degrees. But what is the same amount as 360 in the radian world? 2 pi. So what I could do is I could add 2 pi, and I could subtract 2 pi. Okay. Now, this is in quarters or fourths or whatever you want to call it, so I need to make some common denominator. Oops. So 8 pi over 4 would be the best to use. So this is going to give me 19 pi over 4. So there's a positive answer. Okay. Now when I subtract 2 pi, or I take 11 pi over 4, and I subtract 8 pi over 4, I'm going to get 3 pi over 4. Is that a negative angle? Did I end up with a negative angle? No. I accidentally just found 2 positive coterminal angles because this one was probably like really positive already, like lots of times around the circle. So what could I do at this point if I still needed to get a negative one and I haven't found it yet? Do what? Do it again. Just subtract 360 again until I get to a negative point, or subtract 2 pi again in this case. So now I'm going to take my 3 pi over 4 and subtract 8 pi over 4, and I'm going to get negative 5 pi over 4. And now I'll stop there because now I have a negative representation. Okay. Michael, sorry, I wasn't ignoring your question. Oh, you got it? Okay. All right, so you actually could have done subtraction both times and got a positive and a negative. There's lots of different answers because people could keep adding 2 pi and get more and more positive answers. They could keep subtracting 2 pi and get more and more negative answers. Okay, there's not just one answer for these. There's a lot of them. All right, so our goal.